Welcome to the Midi Quest macro language tutorial. Like the other technical tutorials I've done, if you're not interested in creating drivers or creating instrument panels, this tutorial is honestly not going to do much for you, so I wouldn't suggest spending any time with it. Move on to one of the more user-oriented tutorials. And like the panel tutorial, I'm likely to be all over the place in terms of my explanations. The macros are capable of doing a lot, and I'm just going to try and communicate as much as I can about that as possible, and it's going to be probably a little bit piecemeal as I remember things of importance. Now, little things that you wanted to, I guess, know about macros. I've got this window up here. This is the macro language page, and this covers all of the available macros. Now, you'll notice there's a fair range in style. When we started off doing the macro language some 17 years ago now, we limited ourselves to character mnemonics mostly. T was transmit, R was receive, M was math. As time has progressed, we've started using more sophisticated names for the function calls, such as getEnvironment gets a numeric identifier that tells you what environment the editor is running in. Is it in Midi Quest? Is it in a VST plugin? Is it in an OBT plugin, or MFX, or Studio Connections, or whatever the environment might be? There are all sorts of bank-related commands. These are much longer, so the shorter the command mnemonic, chances are the older the command is in Midi Quest's history. Now, Midi Quest is what we call a compiled, it's not really compiled, it's a binary macro language. So what that means is, okay, a bit of a distraction there. Anyway, I was about to start talking about the macros. Midi Quest uses macros in three main places. One is in the actual instrument panels. You have macros available to any control that edits parameters. You have global macros, which you can select from in here. There are 256 global macros that you can use. Any macro can call any other, any macro from a control can call a global macro. Any global macro can call any other global macro. That's easy. Midi Quest offers no security against recursive calls. So if you have macro 1 call macro 2 and macro 2 calls macro 1 without a way of getting out of that loop, you're going to crash Midi Quest. Next thing, macros are just text. So if you want, and there are a number of developers that do that, you can actually create a separate text file, my macros, say this is my macro number 1, and then I could say I'm just going to create a nonsensical macro just to give you an example. Now, the nice thing about creating macros in a separate text file, Midi Quest macros are compiled in the sense that what you save on disk is not the actual text you type in, it's a binary command equivalent that Midi Quest knows how to execute. And it means that you're not interpreting text commands as you go. It's a lot faster because the binary conversion's already been done and is ready to go. Now, the advantage is speed. The disadvantage is that when you write the file, write your editor to disk, that binary information is stored. Any commentary you might want to put with a macro is lost. So if you want, you can create a separate file, and then you can write comments beside each line to explain what each line does. The semicolon here is the separator. And what happens, you can then take this, if it's macro 1, you can take it when it's finished, paste it into your global macro 1 area. When Midi Quest compiles it, it will throw away all of this text information, but you will still have this saved as a separate file with all of the explanations that go along with it. Now, let's have a look at, so I was talking about that. Macros are also used here in the instrument creator. Each driver can use as many as 3 different macros to receive, transmit, and audition data if it's a bank. And macros are also used in the file conversion window if you have Midi Quest XL and want to use this window to convert files from another format into Midi Quest data format. The conversion macro covers this fairly well. This will give you some additional details as to how macros work. Now, maybe the best way to start off this tutorial is to look at some existing simple macros and explain how they work, and then we can proceed from that point to more complicated items. Let's look at the DX7. To use macros, you need to check the macro I/O, and you should use macros for communication at this point. The older methods are very archaic, and you don't want to start working with them. So in order to receive data, what we need to do is set up a command that actually requests data from the instrument. In the case of the DX7, to receive a bank, this is the sysex macro command. These macros need to be entered in hex, and you will find them in the manuals in hex also. So that makes things fairly easy. You know that it's 5 bytes, so S basically says set a macro. The size of the macro is 5 bytes. An open curl bracket to start. Enter your 5 values, close the curl bracket to end. So in doing this, when the macro is executed, Midi Quest sets its internal pointer to this piece of sysex information. Transmit 5 is a neat little command. In order to have very tight timing, you could do this if you wanted. You could say transmit 5, and it would send out these 5 bytes, and then you execute the receive macro and wait for the 4104 bytes that the DX7 returns. Now the problem here is, what if for some reason, due to really heavy computer use, it takes you a long time between the transmission of this command and when you actually get to execute the receive command? Well, the data could have already arrived at the program and been missed. You don't want that to happen. So transmit TR5 says transmit on the next receive. So instead of transmitting this data immediately, it basically puts it in a buffer and waits for the next receive command, which is here. So when Midi Quest gets to the receive command, it says, is there any message to send out? Yes, there is. So it sets up all the right receive buffers to receive data, then transmits to dump request, and collects the data from your instrument. That's the simplest macro for obtaining data that you will ever see. Now, on the other side, you have transmit. And transmit for the DX7 is a little more complicated than you might imagine. So I'm going to switch to the voice for the moment and then come back to the voice bank and explain. Same simple setup. Send a dump request, set up a dump request, prepare to send it, send the dump request, and receive the data. When you go to send, here's another macro, FA60 followed by some sysex. This says basically format sysex using at the current pointer. I've got six bytes of data that I want to format, and I'm going to start that formatting at byte 0. Midi Quest follows the C style of programming where arrays are referenced. The first entry in array is 0, the next is 1, and so on and so forth. So if you're at least comfortable with C, it's the same naming, the same kind of referencing. So what happens here, we want to send out a single patch. Now if we created this new patch within Midi Quest itself, there's no header information, there's no tail information. You need to be able to add that in yourself. So this adds in the 6 bytes that are used as Midi Quest header. Writes those in. The DX7 uses a checksum calculation. K is the command for generating checksums. There are a number of different options. You can look those up in the online help if you need to. But basically this one says my checksum type is 0. I'm going to start the checksum calculation at offset 6. I'm going to generate a checksum over 155 bytes. I'm going to store the result in offset 161. That's the second last byte in the dump of 163 bytes. We need to put an F7 in as a terminator for this sysex message. And in order to do that, most of the math work you'll do in Midi Quest is in decimal. So here what we're doing is we're assigning 247, which is the same as F7 in hex, to the variable x. We then take the contents of x, write it into offset 162, so that creates our terminator for the sysex message, and then we transmit that piece of sysex out to the instrument. So new commands. M stands for math. You can then, once you've started a math command, you specify a variable that is to receive the result. So in here you could put x, y, w, and z. Those are the temporary variables. Or you could enter one of the permanent variables. That's anything from v0 through v2043. The panel tutorial talks quite a bit about the scope of variables, the area over which they act. You might, if you've got questions about variables, you might want to look at that. If we were to leave this at, let's say 10, so now v10 is receiving the value 247. F followed by a variable. Let's talk about math in general. There are a range of math operations. There's equal, there's plus, there's minus, there's divide, there's anding, there's oring. Those are logical, math, ands, and ors. So the math command allows you to do a lot of things. That sets v10 to 10. This adds 247 to the current value in variable 10. This subtracts 247 from it. You can type in a variable value. So you can say subtract whatever is currently in the variable w from the contents of the variable 10 and store the result in 10. And you can, of course, do variable to variable. So you can say subtract what's in V8 from V10 and put the result in V10. You can do division. So divide by 2. You can do a mod. And if you've done C programming, you'll be familiar with all of these. You can OR. So you can OR 5 into the value. You can AND. So that would AND 3 into the current contents of the variable. So that one macro there allows you to do a lot of different math operations. The F command basically says format a variable into a particular offset. So if we set this back to the way it was, equals 247, we would then say, okay, we want to take the contents of V10, write it at offset 162. T stands for transmit, and you can transmit it out. I'm going to revert back to the original X values for this. So those are a number of the very basic commands that you're going to use for macros. Let's jump back up here and look at the bank. You'll see there's a bit more stuff here. Set 7, set up the 7 bytes and transmit them. This actually turns off the memory protect on a TX7 instrument. You then want the delay. D is a MIDI delay, so it delays the MIDI stream. And it uses, admittedly, an unusual value range that is a result of going back to Midi Quest's original source platform, which was the Amiga back in the 80s. 1000 looks like a pretty big number, but this is actually in 1/100ths of a millisecond. So what you do is you take off the final 2 zeros and say that's my delay in milliseconds. So all you're doing here is delaying 10 milliseconds, which is not very long. You now want to set up to actually transmit your bank. So you format in the header, format 6 bytes starting at offset 0. Do your checksum calculation. Write in your F7 terminator into offset 4103. Then you transmit 4104 bytes and do a MIDI delay and then send out a memory. You basically turn your memory protect switch back on so that the contents of the TX7 is protected. Now let's find something that's maybe a little bit more complicated. You'll find that you probably start using loops fairly early on when you're working with macros. So here's an example of needing loops. Accord M1 multibank. You receive an entire bank of multis as a single dump, and you also send it as a single dump. However, within the multi-bank, each multi in the multi-bank needs its own checksum calculation. So L stands for loop, and so here we're going to loop 32 times. There are 32 voices. There's your checksum calculation, and what we have here is some fairly sophisticated math that we'll use for offsets to go through and generate the 32 necessary checksums. We initialize W to 8. There's your initialization up there. We initialize X to 83. 8 is, so here's your checksum. It's style 3. You can, if you remember back to the DX7, this is where we start the checksum calculation. This is the number of bytes, and this is where it's stored. So you do the first calculation. You start the offset, start at 8, go for 75 bytes, and you write the result into location 83, as specified by the W and X variables. Then you want to move on to the second patch and calculate the checksum for that multi. So what we need to do is advance W and X by 76. Each patch in the K1, or in this case multi, has a size of 76 bytes. So we add 76 to W, we land up now starting at position 84, and we write our result into location 159. And we'll loop this through 32 times, fall out, set the Z value to be the terminator, and transmit the data. So there's an example of a loop. Let's jump back here to Midi Quest's editors. And a DX7 is probably not the best example. Let's pull up something a little more complicated so that you can see just how potentially silly things can get if you want them to. This voice editor actually handles voice editing for all of the different motif instruments. And if you're familiar with the sysex, there is a lot of variation in instrument numbering and all sorts of things that made this a very difficult project. So let's say you choose the parameter element level, and we want to look at the programming part. The levels, what we've done here is we've set up W tells us which of these columns we're working in. So as we switch over here, you'll see W goes 0, 1, 2, and 3. So that initializes the W variable. The Z variable contains the offset into the little section of the sysex dump that handles all of these parameters. So we've set the basic offset from the start of the data as 13, and then we've got 3 different macros that handle basically the extraction and editing of all of these parameters. So macro 104, what does that do? Whoops. If we open up our global macros, sorry, wrong one. Global macros, and let's go and look at 104. It calls macro 83. Gets a result, calls another macro, and returns the final result. If you were to look at macro 83, it contains a lot of conditional macros that make sure that this parameter gets data from the right offset depending on which version of the motif you're working with. So you can create some very complex, I'm going to just step through all of the macros that went into creating this editor. There's some update macros. Now I don't really want to scare you by showing you all of this, because whatever you're creating is probably not going to require anywhere near this level of complexity. But the point I'm trying to make is that Midi Quest is capable of handling very complex editing situations without having to resort to writing actual C code. All of the editors are completely macro based. There is literally no C code. There are no DLLs. There is no breakdown. Some editor librarians, their complicated editors are written as DLLs, and their simple editors are written using a simple macro sort of language. No, everything that Midi Quest does, you've got to be able to accomplish using these macros. So of course the easiest, the simplest, we've already looked at. Let's back up here. Well, let's look at the access virus. This may give us a good medium. And panel edit. Now, this one also is a very simple one. I'm going to put this on pause till I can find a good editor to give you some examples to work from. Well, I've been able to find one that gives me exactly what I want, so I think I will set a few tricks up here and just let you watch them as I work on them. The way you want to create your macros, because it's most efficient, we talked about this in the panel edit tutorial. You want to use retrieve and store macros. And the best way of doing things is to, say, use a global macro to extract data. Let's say that this is going to be macro 5. And we're going to return to Midi Quest the result of macro 5. Here, 121 is the offset, so I'm going to drop that into W. And for storage, we're going to do basically the same thing, except macro 6 is going to store the data. This is your very basic setup, so these will just be 0. You've got a calling macro, a return value in the retrieve area, and the store macro, you just call the store macro. Then you go to the global macros. Macro 5 has got to get data, so FR says read into the variable X using the offset W. That's the offset into the data you want to read from, and it's specified here. And then you just want to say return that result, and that returns the result when the macro ends and calls and returns back to the calling macro. And here, format save basically just saves the contents of X into W. Now, this allows you to use just a variable, the contents of W, very simple read and write, but you can enhance these macros if you need to handle more complex situations. If there's a mistake in the sysex and suddenly you need to move everything from offset 77 down to the end of the sysex down by 1 byte, you can come in here, do a little bit of math, and get that corrected without having to go through and change every single the offsets on every single control to fix up a problem that you found. So there I have this working again, and now what I could do, I'm just going to say I want a way for whatever reason to, let's where's my button? To be able to hide these controls. Well, what you can do, you can group these together, and you can say, okay, these controls are going to be set to use, they're going to be all set to layer number 2. There we go. Actually, I'm not going to use a button, I'm going to use just a numeric for control. I'm going to give it a range of 0 and 1. And let's see, what are we using here? We're using macros 5 and 6. So this is macro 5 and X, and this is macro 6. Layers, if you want to show or hide a layer, you can do that easily enough. And you could say, let's expand this out a little bit and say, okay, if, remember, I'm relying on the fact here that you have viewed the first tutorial on the panel edit and that you understand how data is coming into these macros. So I could say if X is equal to 1, then I want to, LH is layer hide. I want to hide everything that is assigned to layer 2. And then I'm going to end it, and then I say if Q X is 0, so if X is equal to 0, then I'm going to show layer 2, and I'm going to end that conditional macro. So now this has a range of 0 to 1, so there's 0, it's shown, and hide it. What this does lets you set up you can show and hide easily all sorts of sections of your editor, and instead of these old style editors, there's a lot of scrolling. We don't recommend that you make editors that way anymore. We recommend that you use a reasonable, say, 1024 by 768 screen size, and then place all your controls in that area and set them up as layers, and then show and hide. Use a control to show and hide various layers. That is exactly how the large motif editor voice editor is set up. Let's have a look at some more of the available Midi Quest macros. There are conditional macros here. So you can say if followed by a variable. And let's just jump down here. They're all grouped together. There's your conditional execution macros. So you can say if, and then enter a variable, and if that variable is any positive value, so say anything other than 0, the following macro commands are going to get executed until you reach an if end or if x command, which takes you out of that line of execution. You can say if not. In this case, the following commands up until the if end will only execute if the specified variable has a value of 0. You can say if less, and it will execute if the contents of the variable is less than 0. If the contents is less than or equal to 0, if it's greater than 0, greater than or equal to 0, if not equal to 0, if equal to, if not equal to, these two have test another value. So you can say if this variable is not equal to a particular value or the contents of a particular variable, then you execute it, or if it is equal, then you execute it. There are two different if-and conditionals. You can, and I'm going to give you a little example here. Say you want to execute code only if y is equal to 1 and x is equal to 13. This is how you do multiple tests. And in here you would put code for y equal to 1 and x is equal to 13. Now when you're finished, you have two choices. So if you write a macro like this, then if-and basically terminates all previous conditionals. So any command that you type in here will be executed regardless of whether this condition was met or not. Now the alternative is you can use an if-x terminating command, and that only cancels one layer of conditional. So if you were to put a command here, in order for it to be executed, y would still have had to equal 1. So you get a command that would do a terminator, or you could do something like this. If qx is 14, then and this ends up being something like a switch statement. So you can say that if y is 1, then test if x is 13, do something. Then if x is 14, then you do something. Or you could say if x is 15, then you do something else. And then to terminate the whole thing, you'd have a choice. You could do another if x, or to be very certain, you could say put the if-and there, and you would now return to normal program execution. We've talked about these a little bit. fx, take the contents of x and store it wherever you designate. Fy, take the contents of y. Fz, take the contents of z and store it at a specific offset specified by either a single value or a variable. Fa, format it in a string of sysex bytes into the sysex static that is currently pointed to. If you're working in Midi Quest, you should ignore float-related parameters. The Midi Quest macro language can also be used in Infinity, and in Infinity there is support for float manipulation execution. That support is not found in Midi Quest, so don't use float. Don't assign acosatan to atan. None of these commands will work in Midi Quest. Absolute will, it takes the absolute value of a specified variable. Bank edit asks whether the bank editor has an edit window, has a split open, and whether you are editing within a bank window. And the result, if you are editing in that condition, then x will return 1. If it's false, then the result will be stored in x, and it'll be 0. Bank ID, if you are again, if you are editing in a split window situation, you can ask what the ID is of the bank driver that you're editing from, and you can use this for making conditional assumptions as to what parameters to display or whatever you need. Bank V40, again, you can get the V40 value from the bank driver if your editor is currently editing within the bank window. There is a bit invert command which inverts the bit value of each bit in that variable's value. So hopefully you know your bit stuff, and if you don't, chances are you're not going to need this function. Break will break you out of a loop. And let's just step through some of these. We almost never use the buffer command. We've talked about these. Break allows you to break out of a loop and then continues execution from that point. It's hopefully a function that you can avoid using. It's not something that you want to use, but there were a couple of instances where it was necessary for Midi Quest. Midi Quest will automatically channelize both MIDI data and sysex data for you based on the settings in the driver. If within the driver you say that your sysex channel is stored in byte 2 of your sysex data, Midi Quest, before the transmission happens, will automatically format in the current channel. Now, sometimes you want to be able to override that, set your own channel offset, and that's how you do this. Setting n equal to 0 effectively turns it off. CC start enables response to CC messages using macros. CC stop stops that. Delay is a delay within the MIDI stream. You can insert, if you need to be certain that there's a certain amount that there is a delay between two MIDI events, you can insert a delay and that stops it. That is different from sleep. Sleep executes in your display threads. So if for whatever reason you don't want Midi Quest to respond to the user's activity for a given amount of time, and that's specified in milliseconds, then you can do that. I think you can safely ignore. I'm going to skip over the more technical options. You can read those at your leisure. Disk read you're only going to use with the file conversion macro option. Same thing with disk seek. That's really only useful again in the file conversion window. I know this is called quit macro, but that's not quite right. This is an end of loop terminator. So when you're in a loop and you reach this, you go up a loop, up one level. So if you say loop 5, you're going to hit that 5 times. 6th time you come out. You can also use it as a quick way to terminate a macro. So if, for example, I want to stop running the macro if x is equal to 14, I can type that in. And that will break me right out of the macro execution entirely. Writing a data into a variable. We've already talked about these. You'll use that command very frequently. FA we've talked about. There's a factorial command. I'll bet you'll never use it. Float you don't need. This reads a byte in an unformatted fashion. Midi Quest editors normally use what we call formatted byte. You've heard me talk about formatted reads, formatted writes. And what that refers to is the way in which the sysex data is handled. If you choose a type of data where the value of a byte as documented in the sysex is spread over two or more bytes in the real sysex dump. Let me show you the styles here where this is relevant. Okay. Low-high nibble would be one, and high-low nibble is another. 14-bit high-low and 14-bit low-high. What happens in all of these instances is, and I'll use low-high as an example. If you say, I want byte 3, the contents of byte 3 in my data, and my data is formatted to use low-high nibble, then what Midi Quest does is say, okay, each editing byte is actually made up of 2 bytes in the sysex. I'm going to go out, so my byte 0 is byte 0 and 1 in the sysex. My byte 1 from an editing point of view is bytes 2 and 3 in the sysex. My byte 3 from editing for within the editor is actually bytes 6 and 7 within the sysex. So I'll go out and I'll get the contents of byte 6. I'll go out and then get the contents of byte 7. I know that the high nibble is in the second byte, so I'm going to shift that one over 4, add the two together, and return that. All of that math that goes on, you don't see it, you don't need to be concerned about it. All that happens is when you say, I want byte 3, Midi Quest does all of that in the background to build the value and give it to you. So in those situations, you have the option of saying, no, I really want the 4th byte exactly as it is stored in the sysex string. I don't want you, Midi Quest, to go through any of this special math or special joining, and it will take that value that you specify and put it right into one of the variables. Then read byte formatted. This is normally how you want to read data. You want to get the data from a particular offset and store it in a variable, be that W through Z, or you can actually store it in a V variable, anywhere from V0 through V2043. Read byte from data in another block. This is a nice command that only works when the data is being edited within a set. You can actually request, specify an offset, specify an ID, that's the ID of the driver, and the final parameter, if the ID specifies a bank, then you need to specify the voice or patch within the bank that you want to reference. This allows you to actually get current settings from other data blocks within your set editor, and you can make decisions on display or whatever you need. If your editors are somehow interlinked together, this allows you to read data from another editor and there's a corresponding, and the return value is always in the X variable. There is a corresponding macro command that lets you also write that data, write values into another block of sysex. There's another storage command. FT is a special command that actually lets you, normally when you use your S command to set up a small sysex string, normally you can only write values into that buffer. In some special conditions, you want to be able to read values out of that buffer. You can do that with the FT command. These are a number of very early global options. You can allocate and set up an alternate memory pointer to work with. GC is copy. You can copy a block of sysex values from one location to another, either within the current sysex, or if you set up a new pointer, you can copy from the old location into the new location. Free memory, GJ, you should ignore that command. It's no longer valid. You used to be able to move editor controls around in an editor. You can't do that in the same way anymore. You can set Midi Quest global parameter to the new data pointer you've allocated. These are not that frequently used commands, so if you think you need them and you've gotten familiar with all of the other macro stuff, go ahead and have a look at them. GH allows you to hide a control with a specified ID, show a control with a specified ID. You can also show and hide blocks of controls. This hides a block, specify the starting ID and the range to cover, and there's the corresponding show block command. GL and GL2 you may use within your editors. What they do is trigger the receive macro from for the editor that you're currently working in. So if you say send out a little sysex message as an update, and you know that as a result of sending out that command, the instrument is by default going to change maybe a whole set of related parameters. This happens frequently with both Korg and Roland with effects parameters, where you choose an effect and send out a new effect select. The instrument sees that, changes maybe 15 or 20 parameter values. The easiest way to pick up those new parameter values is to use a GL or GL2 command to reload your patch from the instrument into the current editor to collect those updates. We've looked at conditional execution. Checksum command. You can read up on this on yourself. It's quite simple to use and generates the appropriate checksum for virtually all instruments. Loop command we've already talked about. You'll likely use this quite a bit. There is a value limiting option. It ensures that you basically execute limit followed by n, where n is the ID of the control. The control will test that its current value is actually within the valid range of values that the control should have. Under some unusual circumstances, especially when reloading from an instrument, it's possible for a value to be out of range, and this allows you to connect it. Macro execution, as I talked about much earlier, you can actually call a macro from another macro. And this is how you do it. Master layer show and hide was talked about in the panel, original panel discussion. You've got min-max commands to limit. We've talked about math. Floating we're not using. It's possible to, with Midi Quest 10, to actually get the value of a parameter from another editor into the editor that you're currently executing the macro from. And here what you do is specify the parm command. N is going to be the ID of the driver that has this other editor. You need to ensure that that other editor is open before you get a valid value back. And then M is the ID of the control that you want to get that value from. Random. You can generate a random number between 0 and some other number. You can receive bytes. We've talked about that. Receive bytes into a temporary buffer. There's a special role in the macro communication mode that you can use if you want. I try to stay away from it personally. The return command, we've talked about that. The set command, we've talked about that one. Transmit, we've most definitely talked about in transmit on receive. Timeout is an interesting one. There are situations where instruments can have dynamically allocated patches. That means you can have a patch 1, 3, 5, 6, 7, but no patch 2. In this case, Midi Quest is going to request patch 2, and there's a possibility that there will be no response. So you need to have an option for specifying a timeout length, where if nothing happens within that length, Midi Quest goes, oh, I'm not going to get any kind of response back that I'm expecting. I'm going to continue on with my macro execution. That's what the timeout command handles. Variable store and receive. Normally, when an editor is destroyed, any of the values of the V variables here ranging from 0 to 2043, they're just lost. Now, if for whatever reason you want those values to persist, you can actually use the variable store, variable retrieve commands, and when they are executed, so if you type, say, VS25, then the current value of variable 25 will be stored in an INI file. You then, if you want to recover that data, maybe the next editor you want to have a persistent variable that holds the particular state in an editor. The next time the editor is open, you can do a VR, variable read 25, and again that will say, okay, let's get that value of variable 25 that I stored, retrieve it, put it in V25 so that the setup is exactly the same as when I last left it. This is a pretty technical option, but allows you to swap variables around between the variable area and the temporary W, X, Y, Z variables. There are extended read and write commands, FRE and FRE and FWE. read and write as you may gather, and this again allows you to get data settings from another editor. If you're going to be doing that, you can read up on it. It's pretty technical stuff. Most people don't use it. I don't use it. Get commands. There are a whole series of get commands that will query the editor about various states so that you can make decisions if you need to. Get dirty returns whether any of the parameters in the editor have been edited or not. Get host is the same as get environment. Get ID returns in X. And by the way, all of these get commands, unless otherwise noted, return their values in the X variable. So you execute the command, and then if you want to find out the result, look in X. Get ID returns the ID number of the driver whose data you're editing. Get min gets the minimum value from a control. Get max does the same for a control. You can get the pop-up style from a control. You can get the current value of a control within the current editor. You can get the version number of an editor. You also have a series of set control commands. What these commands allow you to do is to actually modify in real time certain parameters about a control. So you can actually have a control that sometimes has a possible range of 0 to 3, but in response to some sort of change, you can execute a command that will make the control then have a range of, say, 2 to 15. So you can set the minimum in real time. You can set the minimum value of a control to a particular value. You can set the maximum value of a control to a particular value. You can set the control's name, set its pop-up style, set its current value. Now, most of these set commands are permanent, so if you're using them while you're developing an editor, basically you need to be aware of that, and if there's a default value that you need to use, you need to set that up when you do the initialization of your editor. Map commands. In the panel edit tutorial, you would have seen a simple example of a map and an example of how that works. Now, there are a whole series of commands that go with this. You can actually create maps in the INI file on disk, and then load these maps up into particular controls. And these are the commands that take care of that. So, copy map allows you to copy a map from a source control to a destination control. You can delete a value out of a map, so basically shrink the size of a map. You can get the current size of a map, get the value of a particular map entry. You can create a map from a table in an INI file on disk. You can set a particular entry in the map to, this one that allows you to set parameters from a source control to a destination control. You can set a map size, and Midi Quest, if you're shrinking the map size, then you will lose values out of the current map. If you're expanding it, Midi Quest keeps all the currently assigned map values, and the new entries at the end are all initialized to 0. And you can specify a particular map value. String lists. Hopefully I've covered the mapping with enough information. Obviously you can read all of this, but I'm just trying to give you a quick overview, really, of all the options that you have. The stringless control is a very complex control, and it, again, has macro commands that can be applied specifically to a stringless control to modify the stringless control in real time. I'm sorry, I can't remember if I talked about this fully or not. These commands that are issued when I say it modifies the control in real time, these control commands stick. So if you make a modification and then you save your panel, the panel is going to be saved with these new values. So if you need particular initialization values, make sure you set them up when you start up your editor. Seeing as we're talking about that, let me just give you a quick example. Here is how you want to handle any initialization that you might need to. Global parameters. You have an initialization macro. You have a parameter here called activate control ID. Don't use it. It's antiquated. It's necessary for some of the older editors, but you don't want to use it for anything new you're doing. All you want to do here is execute a macro. At SoundQuest, by default, the initialization macro is 49. It doesn't have to be 49, but we always do macro 49. Now what happens here is every time the editor window is activated, this macro will get called. So this initialization macro, it just calls macro 49. And then I'm going to go into my global macros, say, okay, macro 49 should do any kind of setup work that needs to be done with this editor. In other words, if this window is active and you need to change the mode on the instrument to make sure that if this is a patch editor, that the instrument is in patch edit mode. Set up your transmit macro in here to do whatever kind of initialization that you need to do. And transmit it. It's 7 bytes. You're going to transmit 7 bytes. Now, if you notice, I said every time this window is activated, this macro gets called. So you may have parameters that need to be initialized once. How do you do things once? Well, you do it like this. I use variable 31. It doesn't need to be 31, but that's what I use. You can do a little trick that basically says if q v31 is 1, then return if end. So this is, and then set it to 1. This little collection of macro statements ensures that any macro stuff here only gets executed the very first time the window is activated. That is where the macro here gets executed every time the window becomes active. How do I do this? Well, the first thing I do is I look at the state of v31. All variables, with the exception of those in the range of v40 through v50, are initialized to 0 when an editor is created. So I know on entry, the first time I enter this macros gets called, I know that v31 is going to be 0. So here I can say, well, if it's been set to 1, then I already know I've been through this macro, and all I'm going to do is exit. There's the square terminator, the exit macro. I end this conditional. Remember, the first time I come in, v31 is 0, so it skips over all of this, and all it does is it sets v31 to 1, and then does any other setup information that you want. Any other time that the window becomes active, it comes in, does your first set of macro commands, gets here, v31 is 1, so you just exit out of the macro. So that's how you set it up. And obviously that and that are considered invalid. So, and actually I don't want to save any of that, so I'm just going to delete it all. Let's jump back to our help file here. So strings, you can clear all the entries in the string list from a macro. You can copy the strings from one string list to another. You can copy a number of strings from one to another. You can set the number of strings in a control. So at one point, at some time, maybe the string list has 7 strings. Because of some change of state, you now only wanted to have 3 strings. So you can set the value to 3, then basically the range changes and you only have those 3 strings listed. You can alter a particular entry within the string list, and so on. These are commands that allow you to, this is a very special group of commands. I'm not actually going to spend time talking about them because they're highly technical and basically place the set window in a special editing mode. If you need information on this beyond what's written here, please contact SoundQuest and we'll try and help you through it. But you'll be pretty much an expert. If you get to the stage where you want to use these commands, you should be an expert at creating your own panels. And here we have an additional set of commands. You can, if you're working with a bank, you can trigger an audition of a particular patch in the bank from within a patch editor using this command. You can, these are all commands that relate to this same advanced area. So I'm going to continue skipping these. Collection commands, these also apply to these special modes. And then we have a number of miscellaneous options. You can set the dirty flag within the editor to basically indicate whether the parameters in the editor have been changed or not. There's a clear error message command that works in conjunction with the set error message command that we'll talk about farther down. You can trigger Midi Quest to perform an edit compare, and you can also place it, do a manual edit compare where you start it, you end it under macro control. You can set the MIDI focus to a particular control number. You can invalidate an area. MPU command, that's dead. That is now ancient. So the set error message, this is the last one that I'm going to talk about. Some instruments, when you request a patch and the instrument doesn't actually, if you've selected one that's out of range or because of the dynamic patch allocation methodology, it doesn't exist, a lot of instruments will send back an error message. So the set error message is followed by a sysex. The way this works, you need to use the set command to set up an error message. That is the message that the instrument is going to respond with if there's some sort of failure. Then you then use the set error message command to set that message up as something that Midi Quest is going to watch for when it is executing a driver to receive sysex data from an instrument. If the instrument does ever send this message out, then after doing a receive command, the x variable is set to a value of -19. So you can watch for -19 as an indicator that the value hasn't, the expected sysex hasn't been received, and that it's not possible to receive it, and you can move on from there. Hopefully you found some of my diatribe here useful. Hopefully you found some of the explanations useful. If there are any questions, please email support@squest.com about particular macros. We'll be happy to try and answer them. If there's anything you would have liked to see covered in these demos that didn't get covered, again, just please send us a note. We'll see what we can do to help you out. Thank you for viewing.